Good evening, everybody. Let me just wait for YouTube to catch up and confirm that we're live. Just waiting for YouTube. And yes, we are live. Haha. Good evening, everybody. And welcome to part 11 of porting Gitflow to Golang. Hello. Welcome to episode 11. We're over a third of the way through the series already. Not bad. Not bad at all. Now, as always, I'm here in the Welsh Valleys. I'm not very Welsh. You'll have to excuse the lack of a Welsh accent. What news from Wales this week? Well, we're out of lockdown, while England's just started its second week of lockdown, I believe. And it's really strange. At the weekend, my wife and I, we went out in the car. It was wet and horrible, so we didn't get very far in terms of actually going out walking. But we had a little bit of a drive around just to get out of the house for a bit, and it's the furthest we've been in the car for months, and it just felt really strange travelling that far. It's just still within Wales, and it's still within South Wales, but it just felt really weird. And we were both surprised, really, at just how strange it felt. Yeah, it was an odd one and very unexpected. What other news? I don't think there really is much more news. I mean, it's great news that there's a vaccine. 2 vaccines tonight. We're still waiting to hear who will get the vaccine and when, so conditions aren't going to go back to normal anytime soon. But there's hope. There's hope. And there's hope on both sides of the Atlantic. Hopefully the transition will go well, and we'll have a better American president. We just need to get a better British government. That'd be nice. Right. So tonight, I've actually moved my controls around a bit. So let's see if I can remember where everything is. There we go. As always, if you're watching this live or you're watching this on catch-up afterwards, please do leave a comment. I'd love to know where you're from, how you found the live stream, and I'd love to hear some news from your part of the world. Doesn't matter if you're watching this weeks afterwards, after this went live. Doesn't matter. I'd love to hear from you. Now, what's the plan for tonight? 2 weeks ago, in our last live stream, we were working on the Git abstraction layer and looking at how we call out to Git. I want to focus on that tonight. I want to get that sorted out. And in particular, I want to sort out how we're going to handle errors arising from calling out to Git. That's what I want to focus on. If I get that sorted, then we've got our building block, our kernel, if you like. I'm making hand gestures, but you can't really see. But if we've got that sorted, we've got our first flagstone, our first foundation stone in place for us to actually start building on. So yeah, that's what we're going to focus on tonight. Just trying to get that right. I reckon we'll be streaming for about 2 hours. I'm not looking to go really beyond that tonight. I have got some work to do, some paid work to do after this. So I need to, when I'm finished with this, I've got other things to do. So I'm not looking to do 3 hours tonight. If we get the Git calling done sooner, we might call it there. We'll see how that goes. If we get it done much sooner, then we will get back to working on our Git abstraction layer and wiring it into workspaces and repos. But I'm content with the idea that the whole of this live stream will end up going on just sorting out this call. All right, let's get into it. Let's switch over to Linux Cam. Right, so that should be Linux Cam. Let me just move things around So the trackpad for the Mac, which is controlling my streaming, is on my right tonight, and the Stream Deck, which controls my camera views, is on my left tonight. So let's see if that works for me better or not. So let me just make sure you can. Right, I can see what you can see. So this is where we left it 2 weeks ago. We'd identified we're gonna have something called call Git. It's going to take a Git path, which is the path to the Git binary, and it's going to take a set of arguments. And it's going to build a pipeline but not execute it. That's what we determined last time. But we started talking about error handling. And I wasn't happy with the error handling options available to me, because it felt like it was really hard for me to standardize how we're going to handle errors. And I said I was going to go away and look at it. And instead of doing that, I've left it for tonight, for us to actually revisit this tonight. So we're going to explore the options. We may end up extending Scriptish to add this error F handler. We may end up doing something else. We'll have to see. But that's what we're working on tonight. Oh, excuse me. Right then, what we got. So the problem we've got is all of our individual functions for all the different things we're going to do with Git ultimately going to come through here, or something like this. That's what's going to happen. And so what we want to do, when it fails, and it's a when, not an if. For example, it may fail because Git isn't installed. It may fail because you're running on Mac OS, and you haven't accepted the license for the Xcode tools. It may fail because we, as in the Gitflow extension, is passing in some parameters that this particular version of Git, the one that's installed locally on the machine where it runs, doesn't actually support. So it can fail, and when it fails, we want to handle that centrally. We don't want to duplicate that across our entire code base. That would be very difficult to test, very unreliable, and this is a good case of where you should dry your code out a bit. And by dry, I mean do not repeat yourself. You don't want to dry code out too much, because then it becomes brittle. It becomes prone to breakage when you change things. So there's a balance to be had for sure. So what we want to do here is somehow we want call Git to work out if there's no, if Git hasn't run at all, or if there's a problem because of the parameters we've passed in. It's rejected those parameters somehow. Now that doesn't mean it can't error. Some of the Git operations we're going to do actually we are intended to generate an error in some circumstances deliberately. I believe we do that when we're looking at merging branches, for example. So we still have to be able to allow some errors to pass through, just not all of them. That's what we're going to try and sort. So the first question has to be, should we actually be building a pipeline? And if so, does it make sense for it to be this pipeline where we do an exec and handle errors like this? I mean, for example, let me put my drink down. For example, we may want to do something like this. We may actually want to pass the error handler in to an exec function. We may want to call it like execf, for example. That could be handy. The idea being, if Git fails to run, we kind of handle that in one go, rather than actually having to pick something up elsewhere in the pipeline. I don't know. Another option might be something like this. Let's have a look. We may add some sort of error handler here. In proper shell scripts, you can write, I believe you can actually set something that will, you can install an error handler before you run code. So maybe we could emulate something like that. I'm not sure. But another option entirely is to avoid Scriptish and its pipelines, and actually just call out to Git ourselves, get the results of that, and then feed that into the pipeline, and feed that into a pipeline. That's also an option. Just because I've built Scriptish to call out to tools doesn't mean we have to use it. We're not forced to use it. As they say, we have choices, we have options. And I'm just weighing up in my own head the differences between them and what we could do. That's the email from YouTube telling me we're live. It's only, how many minutes late? 12 minutes late. Okay. Ah, Rob's here. Hello, Rob. Sorry, I wasn't expecting you tonight. Let me share what Rob said. So hopefully that's readable. So Rob's saying he'd expect a go function to return value and error. And that's absolutely true. You would expect that. That's absolutely true. But the problem with that is the pipeline's built so when you execute it, it returns an error. But what we have is no way to get that error into the response value from the pipeline at the minute, which is kind of why I'm leaning back towards this. That's kind of what I'm leaning back towards. Why are you complaining? I'll look at why that's complaining later, when we get this code compiling. I like the idea that, see, after doing an exec, what does, let me explain this a bit better. So what exec does is it tries to run a command, and the pipeline has a standard out buffer, a standard error buffer, and it captures the status code, the exit code of the process that's been run. And those are part of the pipeline structure. Let's see if this will work. Will you allow me to go through to the pipeline definition? Yes, it will. Excellent. So we're now inside the Scriptish source code. And our pipeline is built from a set of steps which are called a sequence. And if you know your shell programming, you know that ultimately shell scripts are a collection of sequences with a very powerful text replace engine on top of them. We manage that through our pipeline controller. And we also have underneath, we have a pipe. And the pipe is part of our sequence. because a pipeline is just an alias for a sequence. So let's look at a sequence. I'm doing a lot of thinking tonight rather than a lot of programming. I apologize in advance if that's not your shtick. So here's our sequence, and it contains steps. It's got local variables, and it gains a pipe. It's also got its own environment, so we can manage environment variables as well. I always forget about that. It's kind of handy. And our pipe, we're now in, well, we're still in sequence, so we're still part of Scriptish at the minute. Scriptish itself is built on top of several other packages that I built all at the same time to try and give me a lot of reusability for the future. So we build ourselves a pipe. Okay, let's update the Go tool because it wants to. Go def wasn't happy, so now it is. And if we go into the pipeline, it's not going to do it. There we go. We can jump in that way. So pipe is there, but it hasn't pulled it down yet. I'm guessing that's why it's not loading it up. So we'll look at that in a minute. There's three packages. There's pipe, there's envis for managing environment variables, and there's this third one for doing text processing as well, which I can't remember the name of off the top of my head, but we will come across it. Right, so let me answer some more of Rob's questions. So Rob is asking, does every step in the pipeline return a value and error? Right, let's have a look at that. Rather than me try to remember, let's actually have a look. So each step in the pipeline is of this type called command. So let's drill into that. So that's actually a command from the pipe. Here we go. We're going to have to go and get GoPipe and have a look. So let's do that now, because we need that. And go get... I'm probably going to regret this, but let's try this. Borrow digital. Go pipe. Right then. Okay, why did you not work? Goes to tools. I'm sure they're fine when you can remember the incantation, but I cannot remember it off the top of my head right now. So let's have a look in here. GitHub.com, borrow digital, go pipe. Here we go. Right, so let's have a look in here. What I'm gonna do, actually, now we've gone and got it, hopefully the tools have noticed. This would be nice, and hopefully we can now drill into it. Come on, please work. Nope, you're not going to work. There is a limit to how flexible the tools are going to be tonight. So let me just add that folder to my workspace. Get that in here, go source github.com, borrow digital, go pipe. Let's add this in so we can start to have a spot round. Let's have a look at the command. So this is what I'm doing here, is I'm trying to answer Rob's question without guessing. And what we've got, Rob, command is a function that takes a pipe, pointed to a pipe on input, and it returns a value, which is the status code, and an error. That's what we've got. So that leads on to Rob's next question, or statement in this case, about what he's calling impedance mismatching, which I'm going to take that, and Rob will correct me if I'm wrong, is the clash of two different abstractions or two different paradigms in this case. We've got the shell script approach where when you run things, you get back a status code and some text output. That's in one of two buffers, or can be in, you can have different output in both buffers. And then we've got the Go approach, where we normally return a single value and an error if it occurs. Yep, so Rob seems to be agreeing with me on that one. Thank you. Now, seems we've got the pipe open. Wow, September the 25th. This code's nearly 14 months old already. Let's drill into it a little bit more and have a look at what we're doing here. It may help inform our decision. So here's the main pipe structure. We have standard in, which is our input buffer to whatever is happening in the pipe. Now remember, at this point, we don't have to call an external Unix program in our pipe. We've actually got, with Scriptish, we've got our own functions that go into the pipe, operator steps. Every step in a pipe, or a command as far as the Go pipe package is concerned, can write to standard out and standard error, but it's not writing to your terminal, it's writing to an internal buffer. And that's important. If the command returns an error, we actually store that separately, which means it's possible for us to write commands that return errors. That's possible. Which gives me an idea. I'll come back to the moment. We also, for consistency with the shell script model, is we also return status codes, and we've got some constants defined for status OK and status not OK, which I believe is 0 and 1 as well. Then we've got the ability to support separate environments. And we've got this miscellaneous flags structure, which must have been added for a reason, but off the top of my head, I can't remember why we're using that. So we'll have to dig into that if we need it. I wonder why we're using that. The pipe package doesn't care. So when we create a new pipe, we create a new environment, we sort out the buffers, we make sure errors reset. And then let's look at how we run it. That's what I'm interested in. Here we go. The reason I'm interested in this is this affects our choices as well. This is the run command. When a pipeline, once we've built a pipeline and we've added all the steps to it we want to do, and we want to execute it, ultimately the code should come through here. Unless I was really out of my head the day I designed this, but I don't believe I was. Right, so if there's no pipe, we bail, because this is Go. You have to expect null pointers and cope with them. So we run a command. And if we hadn't had an error back, we set it. So that's very important. We've got a fallback here to guarantee there's always an error in case the command itself doesn't return a useful error, because it may return a status code that's not status OK, which I'm pretty certain that varies to 0. And we cope with that just in case. So that's run command. Now that just runs one command at a time. So my guess is, as we dig into Scriptish, which we're going to do in a moment, we need to find out where run command is being called from. Because there's something between, when we execute our steps, there's something between us. So this is scriptish again. That's the path. No, that's not that. Right, let's get scriptish up and have a look. So if we go back to here, and let's jump back into scriptish. Where's the path for that? Ah, let's put it in mods. Cool. Okay, it's worth knowing. So that creates our pipeline. Actually, let's actually add that to our workspace. It's easier to navigate around. These tools are not as good as I would like. Go, package, mod, github.com, GitFlow Digital. Ooh, why isn't scriptish there? That caught me out. Oh, the text processing package is called glob. There we go, and we've got another one on top of it called shell expand as well. We'll look at those another time. All right, so mod, github.com, Gambaro, go scriptish. So it's there. Oh, that's cool. So what I've done, let me just explain this, because I've learned something new about VS Code this evening. Clicked on the tab, and we've got the breadcrumb here just below the tab. If I click on any of these folders, I actually get something I can navigate through, which is really handy. I didn't know we had that. God, that's nice. So what I am looking for, I'm guessing it's going to be, let's try the sequence controller, because that's just a type. Huh. So let's have a look and see. The list controller, we're a pipeline, we're not a list. I'll explain the difference another time. So I'll look at the pipeline controller. Does that actually execute? There we go. There we go. So when we run our pipeline, it comes through here. And we've got this because we can build two types of pipelines. Well, two types of sequences we support. We support pipelines and we support lists. And those are things in shell programming, and they are different. And the differences will bite you on the backside if you don't know much about them. Basically, a pipeline fails if any of the commands. Sorry, the pipeline executes everything in sequence, and if something goes wrong, the pipeline fails. In a list, if something goes wrong, the pipeline continues to run. The sequence, sorry, continues to run, and that's the difference between a pipeline and a list. But this is handy because we can see here what happens. Oh, that's cool. We actually return a function. Sorry. It's been a while since I've read this code, and it's nice to revisit it and be reminded about my design. So what we do is we do some prep work on the pipe, which is important to us. We run the next step, and then we check. If the next step has returned an error, we bail. We don't continue, which is really handy. So that means we can actually do this. We can do something like this, where we can actually run a step in the pipeline that says if there's an error, don't go any further. Except we can't. My statement there was wrong. And the reason it was wrong, of course, is if exec fails to run, this never gets executed. Because this is a step in our sequence. This is the next step in our sequence. So if exec fails for any reason, we're not going to run this. The pipeline itself will fail. So what we've just determined is, as scriptish stands today, This here is definitely not an option. We can't do it. We absolutely can't do this. So what else is our options? Let's go back to Scriptish for a moment. And what I want to do, let's actually look at the code for exec. And exec is going to be a source, so it's going to be prefixed with the word source. Let's have a look down here. There we go. Let's go have a read of it. So what does exec do? All it does is return a function that has the type signature of a command. Now, if you're a PHP programmer, the idea of function signatures may be new to you, maybe something you're not used to. But most languages have type systems that actually allow you to create a type that describes a function, which allows us to safely create and pass functions around, which is really handy. So I'm just looking at this to see what our options are. So we execute. If it goes wrong, we return an error straight away. We wait for it to finish. We populate our output buffers. We get the status code, and then we return how we are. So command wait can return an error, and we don't care whether it's returned an error or not. We want that output. So that's what we've got. So at the minute, we could build something that wraps exec. Let's have a look. So command is from Scriptish. So we could do something that does something like this. Now we know scriptish.exec. Unpack the args. So that builds us a function. We could then run that. And come on, are you going to give me any help here? Why can't I do run command? We could try running it. And then what we could do here is we could look at the output here. So I think this is where we're going with this. We're going to build a Scriptish command. Which means we're not building a pipeline anymore. What we are returning here is a Scriptish command. That's what we're doing. So what that will do, I'm guessing we've got call git in here, which is why it's turned. That's silly. So we would do something like call git in here. comma? Yes, you want a comma. Just making sure everything's okay. So what happens is we've effectively created our own, drop the pencil I'm playing with, and headbutted the microphone. So it's that kind of day. So what we were doing here is we are effectively creating our own little Scriptures extension without having to modify Scriptures itself. I'm just trying to keep all the tools happy. We don't need that anymore. Right, so that should keep that happy. And you're not happy because .trim string. There we go, it keeps you happy. You'll stop complaining up there. Now why are you unhappy? Missing return. Right, so these are complaining at us because there's a missing return. That's all right. Just hit that as a return there, that's good. And we do a return here. We don't care about that anymore. Right. Always return an error. It's just easier. Right, there we go. So what I've done now is we've got our two sample commands that we worked on 2 weeks ago, if anyone can remember that back that far. And if we make call git something that we can put in into a pipeline, all of a sudden our code becomes a lot simpler, because now our attempt to get a version is very simple. We just call git with the ---- version string, and whatever goes wrong will get reported back by the error, which is cool. Same here for get current branch. We call git to get the status. We go and find the line that's got a star on it. And we find every line that says no branch. We cut it up and we return this thing. So as long as call git is returning the call git itself returns a useful error for the caller to determine, we're okay. And what we can do with this, we can define a set of errors that call git is going to return, and we can make sure they're easy to detect and easy to handle, so that we don't, in the back ends and elsewhere in the code, we don't have to have lots of individual code to handle that. We can probably wrap that up somehow. That feels good to me. And the reason it feels good is because this code now looks nice. So does this code. We've got all these git operations to build, and we're going to be building far more than we've got listed here. Go back several weeks, we made a list of all the operations we think we're going to need based on the current code. And so the proof of a design of something is in how you use it. And this feels good. This looks good. We can just call git and just treat it as another action, another command in a Scriptures pipeline. That feels nice. So what we have to do now is make this happy. That's what we need to do. Now then, I don't think Scriptures re-exports the pipe. Let's have a look. We may need a Scriptures release here. We could So one thing we could do is actually import this from pipe and then do what Scriptish itself does. That's not Scriptish. This is Scriptish. Now the command we had open has gone. That's annoying. Where did that go? I know what happened there. I didn't pin it. Let's go back to exec. There we go. Double click it so it remains open. Oh, pipe is exported by Scriptish. Pipe is exported by Scriptish. All right. So what we can do here, we can do a scriptish.pipe. Right. So now what we need to do here is that returns a function, and you're complaining because I have not initialized the variable of memory. There we go. And now you are complaining because too many. So do I just do that then? No, it's far too simple. Rest operators. Right then, let me have a look at how you use the spread operator in Golang. Let's have a look. It goes afterwards. You unpack afterwards. That's fair enough. Right, one moment. Ugh. That's all right. Just checking out Twitter notification, but it wasn't anyone about the live stream. So exec takes just a set of args. Aha! So this is our problem here. Is git path and args are all part of the same thing. So the reason it's complaining, that syntax is correct, but exec just expects a list of args. So I've got to figure out how to put git path and args together efficiently. I'll have to dig into that and see what I've got to do there. Now, how would we do that? That is a good question. The last thing I want to do is to have to build an array. Oh. It could be I've actually designed this wrong. It could be exec actually should have a first argument here to make it a lot easier to do. A bit like I've done internally. That's not internally, that's the Golang standard library. That's not my code. I can't take credit for that. How am I going to do this? Because I really do want to be able to just pass that in. And most languages wouldn't give a shit. They really wouldn't. But these are all strings. They're going to something that takes a spread operator of strings. They just pass them in. But this, why are you doing that? Too many arguments in call. Have string and then an unpacked array of strings. It just wants a set of strings. Let's have a look. Is there anything I can do about that? Because that would be nice. Interesting. Why does variadic come? Why does this come up in slices? Tricks, maybe? It's not obvious to me why Google's picked that as an answer. Right, then let's have a look at variadic. Variadic options. Functional options for friendly APIs, that is something we will come back to later on. We're not there yet with that. That blog post there is very, very important. It really, if you ever get to see any of my TypeScript work, and I'll probably do some TypeScript live streams over the Christmas holidays. Yeah, functional options I am all in on. I really am. They are fantastic as a way to extend code in a flexible way. But let's see if we can understand what's going on here. You're going to force me to put all this into a variable, aren't you? Yeah, I bet you are. Let's have a look at this. It's a few years old. The reason I skipped the top hit is it's possible Golang's evolved a bit since this was written. I mean, it's exactly 3 years old, so let's have a quick read. Rob's given me a thumbs up. I'm not quite sure what for. Maybe it's the design I've come up with. I wasn't paying attention when the thumb came up, and I actually have no sound effects, so I actually can't hear any comments and reactions. So let's have a look. Right. Right, so I'm just scrolling through this pretty quickly. I'm really hoping there's something silly I'm doing that will actually help me out here, because this is a string. This is a set of strings that I'm unpacking. You would hope it, right, it's quite possible I've got my, so args is actually an array of strings and I want to unpack them. It shouldn't care. It really shouldn't care. That is some, right, unless I've made a syntactic error, which is very possible, but if my syntax is correct for how you unpack an array, or a slice in, in Golang terms, the compiler really shouldn't care. That's annoying, he says, trying to be polite. Ba-ba-bum. Yeah. You pass an existing slice to a variadic function by postfixing it with the 3 dots to unpack it. This is like passing the params as usual. That's what it says here on this particular blog post. But we've just proven that the compiler doesn't treat that, however, the same. Aha! And here's why. The pass slice will be used inside the function. No new slice will be created. So it doesn't actually unpack and then repack. Now that kind of makes sense. We've got it wants to pass the slice in intact, which it can't do because I've got this other parameter. At which point you would hope the compiler would just sort this out for us. If I've actually got to build I've actually got to do something like this. Now, how would I do this? Bear with me. Right, I'm just looking to see a bit of syntax. Rob's saying he would prepend the additional item to the array and then extract with double dot. That's exactly what I'm looking to do, but I think I've actually got to build a new array. I don't think I can prepend, can I? Let's have a look. How do you prepend to a slice? Ba-ba-bum. That just builds a new slice. That doesn't actually prepend. It'd be a method that returns a new slice in Go. Says Rob. Let's have a look at this. Haha. So we can do append. Let me get this right. And we can do Args like that in theory. Or we can do if I do that. So we can do that. We shouldn't have to. Sorry, but that's annoying. It's annoying that we have to do that. It's annoying that the compiler can't handle that for us and we're forced instead to handle it ourselves. That annoys me. But hey, what can you do? Right then, so Rob's just said that Go is nothing if not explicit. That's one word to use. Okay. So anyone who's just listening and isn't actually viewing the screen, what I've done is I've just added some comments to my code to remind me of why I've had to do this step. At least we were able to do it. At least we found a way. But what we have to do, we have to build a new slice by passing in the git path and then a set of arguments. That feels so wrong. I am sorely tempted to change Os Exec signature so that it always takes a path to the binary first, because there's always guaranteed to be one command, and then we can avoid having to jump through hoops like this. That is seriously tempting. The thing is, it's a backwards compatibility break. Any code that uses scriptish, and I'd be surprised if there is any, but you never know. I mean, as far hardly anyone knows that scriptish exists after all. Yeah, I'd have to create a version 2 of the package for that. Yeah. Reason I'm laughing is Rob's just said he doesn't think it's a coincidence that the built-in exec package, its command, takes a command and then arguments. Yeah. I think this is a case where the way I'm doing this, the way I've designed Scriptish, does actually make Scriptish a little harder, a little more effort to consume. And I think this needs fixing. But I don't want to do it on camera today. I think that's one for me to go away and do before the next live stream, perhaps, so that we can get rid of this nonsense. I'm just thinking that one good reason about the compiler complaining is, as Rob says, you've got to be explicit. You've actually forced to build a new slice, and people can see that you're paying that penalty. But I want that penalty gone. We will fix Scriptish for next week. I don't want to try and do another release of Scriptish in the 1 hour we've got available. And besides, if I wasn't the author of Scriptish, it wouldn't be an option. Golang is not a language where you fork and maintain your own copies of packages unless you're a masochist. Because the path to the package is part of your import statements everywhere. Forking a package in Go is so painful. It's just not worth it. So we're going to, for tonight, we're going to pretend that like we can't change Scriptish, and then next week, miraculously, there'll be a new version. And I might live stream the work on Scriptish if anyone's interested. If anyone is interested and you're watching this at any time, leave me a comment to let me know. Right, back to our work. And we're about an hour through, by the way. So this feels good. It feels like we're on pace tonight. And I know all we've done is managed... What's this? I'm not sure how many lines of that we've selected. About 11 lines. I know we've only managed about 11 lines. But it's not about the amount of code you ship. It's the amount of code you ship that sticks. That's very important. And certainly as you go through your career, it pays to be fast, don't get me wrong. Being able to ship functions fast is great. But there's also value in being able to really surgically get into something and ship the right design. Something that's fit for purpose, not just today, but for going forward as well. And it helps if you can switch between both depending on the task. So I'm not unhappy about how little code we're writing tonight, because if we get this right, and the nice thing about this, by the way, of course, is we're able to hide my this redesign with Scriptish that needs to be done. We're able to hide that from the rest of our code anyway. So it won't matter. The rest of our code, it won't matter that we're having to do this new slice in the short term. But by getting this right, all the Git operations that we need to start writing next week will be easy to do. Now, let's look at the error handling then. Our second part of tonight's thing, which is our centralized error handling. What can go wrong? Let's make some notes about what can go wrong, and we'll actually put them into the code here. Well, first thing is, if there's no error, we don't care. We can return. Right then. So if p.ok and you are a function, we can return, because we're a command. Well, this is interesting. Just thinking this through, because what I was going to do was do p.status code Are you a property or are you a function? You're a function. P.error. I was going to return. This is what I was going to do first. If we're good, we return the status code and we return the error. Now we're getting those from our pipeline. But our command's also running as part of the same pipeline. We're not and the reason we're doing that is I don't want to have to mess about with copying input and output buffers for our command that calls scriptish. But if we're returning a status code and an error that's then written back into the pipeline, it shouldn't cause any sort of loops or anything. It's just a bit, I don't know, it's a bit inelegant, but we can live with that. So, alright, so change the comment, say, are we good? And then if we get here, we're not good. What happened? So what can go wrong? What type of errors are we going to need to define? So the first thing is no get binary or get failed to execute. That's the first thing we want to pick up. Now then, let me have a look. We don't create any new errors ourselves when we do an exec. We're relying on the existing errors reported by Golang's Os Exec. So let's have a look and see what errors it defines. Let's have a look at what it does. So we get it. What have we got down here? We've got type error. So we get an exit error. If something went wrong, we get an exit error. And that can be converted into an error. No, it just returns a string. Right. So what I'm looking to do is see if there's anything we can reuse, anything we can tap into. So we get a process state. So there's an exit code. Whether or not it exited, we get a process ID, get a string. We get something that's system dependent, which we are probably not. I was going to say we're not going to touch, but I think we may have to. That's annoying because we don't want platform-specific code if we can avoid it. I would really, really prefer not to dig into that. Really don't want to dig into that. We don't care about resource usage, so that's not a thing. Let's have a look and see if anyone's done any error handling around this. What have we got? Well, one thing we can do is look at the actual testing. So here we go. So this is the actual source code for testing the Os Exec package and the exec function itself. Alright, I'm not going to worry about that. So I'm just going through and having a look to see what we've got to work with. just printing errors out. Right. Not very helpful. See, we get an exec error. I need to double check what this syntax is. I don't know if that's some sort of typecast that it's comparing for. I'm not sure. It's not. It could be a little easier to work with. Certainly at first glance. I mean, it just reminds me of a short conversation on Twitter today where one of my friends, Paul Waring, had done some work in Go to ship a command, shipped it to Windows, and he built it on Linux. One of the things he said was that he found Go a little hard to figure out what half these APIs do, just from the docs. And I'm certainly having sympathy with him right now on that one. This code could be better written, especially for the casual reader. Yeah. So if errors nil, unexpected success, errors not equals nil. But these tests, I don't know. At first glance, they're not explicitly checking for the exact errors that are coming back in a way that we can easily latch onto and use ourselves. So let's stop there. And let's see if we can find anything we can work with. Right. So I don't care about showing the output. What I want to know is what went wrong. We've got standard out, we've got standard error. I'm not worried about that. I want the errors. Not worried about any of that. Not worried about that. Not worried about that because Scriptish handles all of this for us. Oh. That wasn't very good. Right, one moment. What test did I write for Scriptish? Have I cracked this in the past? So this is a very different style of how to lay out your test, by the way, compared to what we were just reading from the official Go code. I will do a proper live stream and session on this. I've promised Steve I would do this, and actually haven't done it yet. But I very much come up from a point of view at tests, well, our experimental science, and we've got this 3 stages. I think I said this on the last live stream. We've got a very clear setup stage. We then exercise the unit under test, which in our case is our pipeline. And we check the results. So do we have anything in here about when an error happens? So exec sets error if command cannot be run. So we get a path error. Right. So it looks to me that this syntax here is actually proving is actually some kind of typecast, and is proving whether or not the typecast worked or not. And we get back the converted type, which we're throwing away, and whether or not it succeeded. So not quite an error. So we get OK, and then yeah, so we can get back it's a path error. So we need to find out all the different errors that the OS module defines. Let me jump back to here, OS. I'm sure if you live in Go all the time, the error handling's fine, but when you're just dipping like this, I do find it a bit bloody primitive. Let's go and find some types. And of course it's not listed there. Control F. Path error. Right then, let's go find that. So where was that? I was just here and I missed it. So we get a link error, we get a path error. So one concern I've got about these is they're really hard to discover. Excuse me. Got a syscall error. But how do you discover these? These are not easy to find. I mean, we know there's an exec error. But it doesn't appear in here. If we jump in here, do we get exec error in here? We get exit error. I have to share this. Rob's first law of Golang error handling. You find the errors you missed when your app crashes in production. And that's why I don't build services out of Go. I think if you're trying to build robust and correct applications, Go performs well, don't get me wrong, but I think there's better languages for it. This is one of many reasons why I don't work at Google, including the fact that they'd never hire someone like me anyway. I'm not good material for Google. Right, so where does this leave us? This leaves us with the situation where we're not exactly sure what these errors are going to look like when they come back. Also, that can be nil. We're not returning an error because we're good. So what we may actually have to do is we may actually have to build the tests for callgit, crash it in many different and amusing ways, and use that to fill out our error handling. That's what we may have to do. Take Rob's approach, I guess. Which is frustrating because it is a bit error prone, and we can only write tests for what we know about. So let's just stick some stuff in here. Right. So the two we can expect is path error and exit error. So there's no get binary there, and we need to return an error. So we're going to have to define some kind of error. Errors.go. We'll chuck something in here. Package backends. These are just placeholder names. Return scriptish.status not okay, and we'll have a a new probably isn't a new. We want a no get binary. We'll return that. No get binary is an invalid type, and yet VS Code is not highlighting it as broken. I apologise. I thought the Go tools were a bit better than this. They do seem a bit, It works as an invalid type. It's not telling me that this is broken at this point. So that's a path error. If we get here, the binary ran but wasn't happy. Okay, so the main thing we want to do here is what happens when we call Git and we don't pass in parameters it can support. We get a thing called error and a thing called usage. We get a return of 129, a status code of 129. So we may be able to use that as well. Depends how reliable that is. Git source code. I have the Git source code on here. Where's that gone? Let's have a look. Let's go digging around in the C code, because why not? Where would that be? Is it going to be centralized? I don't even know what to search for at the minute. I'm just scrolling down, see if anything looks obvious. Let's have a look at how commit's implemented. Do I want to install the recommendations for C? Not today, I don't, but there's a good idea. So is there an entry point? So what I'm looking for is the function in here that gets called to see if I can actually it may even have a main, thinking about it. A run commit hook, commit header, get merge parent. I was hoping there'd be some sort of entry point. It might actually be exported in the header file. This is not C++. Stop that. There's a structure. Export a few entry points. Interesting. Void parse commit or dial. Love that. The reason I was thinking there might be a main is I was thinking that maybe this actually compiles down to git minus commit. Is there a git? See, there is actually a git commit binary, but it's possible that they're top and tailing it. You can do funky things with C, including feeding the compiler multiple files to produce a single output. Oh, tricks of my youth. Common main.c, it's right there, right in front of me. So if you were yelling at the screen for the last 5 minutes that I'm an idiot, you're absolutely right. So let's have a look. Well, that's not much use, is it? And unfortunately, I don't have the means to go through that. So where's command main defined? There's one in daemon.c. There's one in get.c. Let's have a look. So there's a die function or macro. That's handy. We exit 1 if we show usage. Not helpful because I'm willing to bet plenty of other git commands exit with the value 1. Then there's an infinite loop where again there's an exit with 1 if there's an error. And yeah, the return value of the C commands, we often exiting in 1, a status code of 1. We're not guaranteed they're using that uniquely. In fact, we can do better than that. We can actually look into it. Where are we exiting across the code? Yeah, they're not Git. Unfortunately, this does not use the Unix status codes in a non-ambiguous way. We can't use the status codes to reliably determine centrally why something failed. It is not reliable for that. Lots of Perl files. So parse options. Right. Okay, so Rob's just chipped in. And Rob's just pointed out that in his own experience, exit status codes are rarely unique. And that's certainly what we're seeing here. Now, but also what we can see, Just remove that comment again, thank you. What we can see though is, this is a little promising. We can see an exit code of 129 means that we've passed in some unsupported flags. So that's something we can handle. So let's make a note of that. That's important. Now, in what's 128? Don't know. That's a nice typo. Multi-word arg should use dash to separate words, and it's been there for 7 years. I say it's a typo because it looks out of place, but you never know. That may actually be deliberate. Yeah, so we can reliably use exit code 129 to mean it doesn't like what we've passed in. That looks reliable. Maybe the only thing that is. $128. There's something nagging my memory about. Oh, 127 I think is what bash returns if something goes wrong. So I'm struggling to work out what 128 means. They use it quite a bit. They also use 141. It looks like a pipe error, but there's no guarantees of that. So 127 shell execution failed. They're using it there. Here we go, lots of 128s. So it looks like they're using exit code 128 as an internal failure in Git. That's how I'm reading that at the minute. I could be wrong, but I mean, you're sending a line, receiving a line. If you can't receive the line, you exit 128. Again, you're expecting to receive a line. If you don't get it, you bail with exit 128. That. A die built in returns out 128. Errors don't actually return, don't actually exit with an error. They've got tests for, excuse me, catching multiple calls, or die calling. It's entertaining. Yeah, I'm going to say we can reliably use status code 128 to say we've hit a bug, a detected bug in Git itself. I'm going to say we can treat that as the equivalent of a 500 internal server error for those of us who predominantly work in HTTP. I think we can say. I think we're on good grounds with that. But then you've got things here where apply can return it. Die nicely. Has an exit 128. I'm just looking through to see if there's anything obvious that tells us we can't rely on 128. See, this worries me because we've got the situation here inside the merge command where merge recursive, the return value of that is assigned to something called clean, which, you know, and if clean's less than 0, it exits 128. Aha! It is handy. So this is, I think this is GitLens extension in VS Code. Is actually putting up the commit message for each line if I hover over it too long, or hover over the right section of it. And they're on about here about commands having failed fatally with an exit code 128. What was this one here? So we may have to be a bit more general, and we may have to say exit code 128 means Git failed unexpectedly. It didn't expect to exit. It's not supposed to build. It's not supposed to break like this. That might be what we've got to do with it. And it might be we're going to end up building this out. Oh, we've got some more right down here. Oh, it's alright. I'm not worried about that a bit. It might be we've actually got to start with this as an assumption, build it out, and go from there. Now, before I go any further, let me have a search to see whether or not there's any documentation that would help us. Let's try and close all these C files. What is this doing? Git bisect as a shell script. It's evaluating the text. Really bad run error. I'm not sure how useful that is in practice, so I'm going to ignore that. What I'm looking for is see if there's any sort of, anyone's actually documented any of this. Because we can't rule that out. And if they have, we could really do with actually knowing it. What's this? See, they've even got helper shell scripts are doing this. Right, some documentation. Exit code between 128 and 255 are special to Git bisect run. Well, we know that's not true because we've just seen other examples of that in the shell, in the code. So that's not a reliable statement. Dies for fatal application errors. It prints a message to the user and exits with status 128. Usage exits with status 129. Error is for non-fatal library errors. Returns a -1. Right. So status 128 is basically basically a fatal error. The problem is we're not sure about when it reaches us, when we see it. As the person calling the Git binary, we're not sure if we can assign any meaning to it reliably. My faith in that is definitely wavering as we go through this. It has to be said, it's definitely wavering. Is this language files? Let's actually have a look at the structure here. Let's search for 128 in here. Nothing. What's this? Exit status. A fatal error was encountered. Yep. It's a catch-all. It's a right. So right, we're going to have to treat exit code 128. Something went wrong. It's not meant to go wrong. It's a catch-all status, which means we can't do anything for it down here. We can't catch. Well, let's make a note of that. So I'm just writing some notes which are actually going to form part of the comments of this code. So what I'm saying is we can't, we said can't catch. I'm going to say we can't react to exit code 128 here, because all it means is that a fatal error occurred in Git. We've got no way of knowing whether the caller needs to know exit code 128 occurred or not. Right, so we can't do anything about that. So basically the only exit code we can reliably do anything about is error code 129. We can do something about that. So we're going to define ourselves an error. And we're going to return that to say that there was an arguments error. That's what we're going to do. So we can pass it back. This blog post is just over a year old, and I'm looking at it's on the Golang blog, which will work nicely for us. So error at its heart, isn't it? Is a interface, is what this is telling us. So what we're going to do, errors. We're going to create a struct, and then we're going to do func no get binary error turns a string. And so what do we want inside our error structure? We want the command and we want the arguments. That's what we want. And of course that goes there. Right. So no get binary error is returned. When we don't care about the arguments for that, so one moment, I'm just going to grab this because I want to define another one in a moment. We don't need arguments there. So the no get binary error is returned when we failed to execute the given get binary, and we are going to return a string. Execute plus e dot command, and we should probably stick we should probably have a wrapped error in there as well, and typo, that's why it's complaining. Right. So what we're saying is when we get a no get binary error, we're going to have the path that failed to execute, and we're also going to have ourselves a wrapped error. Now, do we want to make this opaque so people can't look inside it? I'm going to say no for that. I'm going to leave it as it is. How are we doing for time? We're about 15 minutes. This is okay. So the second error we want is on a get args error. Get args error is returned when we've called get with arguments, and it does not support. That's what we want. So we'll get args error, return unsupported arguments to get plus e dot command plus colon plus e dot args, which I bet I can't do, and I bet I can't unpack it. Let's try unpacking that there. Nope, can't unpack it. That was too much to hope for. Right, so we need to unpack that and get that sorted. We'll do that in a minute. Going back to call get, if we get that, right, we want to return a no get binary error when something fails. Command is get path, and args is args. It's probably the wrong syntax. There we go. It's not complaining though, so we will let it go. Right then. If p.status code equals 129, we want to return scriptish.status not okay, and what we want to create is a get args error. And what the command is get path, args is args. Now, has anyone spotted the problem here? There's no args in our no get binary error, but the Go tools haven't complained about it, which is a bit shocking. Is there anything in here? Nope, it's not complaining in here. It should be, really. So that's a bit disappointing. Let's grab the error from there. We're not going to bother returning the error that came back if we get a status code 129. We don't care. We're going to treat that as an Args error. We're good. I'm just going to add here at the bottom. In fact, any other errors, any other status exit codes need to be passed to the caller to handle in their own way. Right. So we return p dot status code and p dot error. There we go. We have our very basic centralized error handling that we wanted. Still going to make errors.go compile, but it's in good company because we've been sketching this code out and my Go syntax doesn't stick at the minute because I'm not working in Go on a regular basis right now. It's probably not the only file that doesn't compile, but this is feeling good to me. So just to recap where we are, we're building something that we can call from a pipeline that's actually taking full advantage of what Scriptish can already do. So it's wrapping an exec call. If everything works, we say we're good. If it doesn't work, first of all, we're checking if we've got a path error, because if so, we're converting that to an error that says there's no Git binary. If we get the special status code of 129, then what we do is we say that we've had an arguments error, which is going to be handy for supporting the different backends. We may end up in the situation that, going back 20 odd years now, where I was actually making portable C code, and one of the ways we handled that was calling lots of different things until something worked in order to work out what particular functionality existed on the platform we were installed on. We may have to resort to brute force like that. I don't want to, because I don't want to be running the Git binary more than I need to. And let's be honest, we're already adding a level of robustness over and above what the existing extension has, the shell script based Gitflow extension has. We're going further, and we may not need to. So this may be sufficient. Oh dear. Actually, Rob, I didn't. So I've just put up on the screen Rob's comment that you missed the quotation rounds about portable for that C code. I was writing C code that had to run on 24 different versions of Unix. I mean 24 different Unix systems, not just variations, actual different Unix platforms back in the day when Linux was rarely used. In fact, I was the main user of Linux, of this software, because my workstation ran Linux, because we weren't going to spend thousands and thousands and tens of thousands of pounds on a Unix workstation for my project. That code was incredibly portable. I got very good at writing portable C code, and it stood me in good stead for many years afterwards. It can be done. Whether people do it today is a different matter, and I'll let you in on a little secret. There was no autoconf involved. Oh, Rob's cheerleading from the sidelines for me. Thank you very much. That portable C code does still exist on the internet, but I'm not telling anyone where to go and look for it. Rob says he notes he didn't include Windows in that list. No, because Unix. Why would I put C code to run on Windows 3.1, which is what was around at the time? I would actually, I want my code to run on a proper operating system. Windows wasn't an operating system back then. It was a GUI shell on top of DOS. Different world today, but back then Windows wasn't an operating system. He says, feeling very defensive. Right. Here we go. NT 3.5. Let me tell a little story about Windows NT 3.5, because one of my many incredibly minor claims to fame is I actually built and ran the first Windows NT 3.5 server that we had at the University of Sheffield. I was actually on staff at the University of Sheffield for a couple of years. I am not responding to that one, Rob. I'm going to stick with NT for the minute. NT 3.5 architecturally was a wonderful design. There's a reason Microsoft abandoned it and went very differently with NT version 4. And that's the performance. The hardware of the day couldn't run a proper operating system design like Windows NT 3.5. Couldn't do it. OS 2 had the same problem. If anyone who from IBM ever gets to watch this who had any involvement in the old days of OS 2, hopefully they'll be able to corroborate. What killed OS 2 wasn't just the behavior of Microsoft by releasing Windows instead, but it was just it couldn't run on Intel hardware at the time. Building a proper operating system with proper memory management, the things we take for granted today, the hardware wasn't performant enough back then. Very different world. Very different world. And I'm still not responding to your follow-up comment, Rob. I'll let other people do that. Right, we've got about 5 minutes left for the scheduled 2 hours. I would like to get this compiling. Rob says he doesn't miss those days. For the record, Rob's even older than me. And I'm very used to being the oldest engineer in the room or on a project these days. And Rob's even older. He's got even less hair than me. Ah, dear. Right, 5 minutes. How do we unpack a slice to append it to a string? Let's quickly look at that. Is there a quick way to do that? Is there a better way to phrase a question? Append slice to string. Of course, everything goes the other way. Everything this talks about appending to build slices. I don't want to concatenate, I want to expand it. We may have to do it the old-fashioned way. Right, it doesn't like that. Rob goes as no implode. That's a good question, actually. Golang implode string. We've got string.join. So we can do it that way. Strings.join. Yes. Good question, Rob. That's far more sensible than I was doing. Let's make this a bit more readable. Go format can always sort it out afterwards. E.args. There's a space. And now, why are you unhappy? Invalid operator. Ugh. Come on. You're not Python, you don't care about things. And untyped rune. Do that. Thank you. There we go. Right then. So that should now work. Now, why is that unhappy? Undefined error. Of course it is. Right then. See, now we're getting more errors visible elsewhere. In call git, now we fixed one thing that wasn't compiling. Now it's telling me off for this. So you're saying non-git binary doesn't implement error, so we can't do that. Again, this is where I'm having to look up Go syntax, which is slowing me down. But no git binary should implement error because I've defined an error. What else do I need to do? What else do I need to do? I've just got to return a string. That's the only thing the interface does. What am I missing? Okay. So you've got the ability to unwrap errors. This blog post needs better reading. There's a lot more information in here that I need to actually work with. This is really handy, actually. But I am not 100% sure why it's unhappy. Ah, it's got a pointer receiver, right. I have seen that one before. So what happened here is, think of this a bit as a bit like Python's self parameter, conceptually at least. It can be a pointer, which gives you read-write access, or it can be a value, which gives you read-only access. And the error interface takes a read-only value. Errors are effectively immutable. So that's that done. And just out of curiosity, I'm going to try building this. I don't expect it to compile. No, we've got all of our other code that prevents it compiling at this point. So we can't compile it and we can't do any unit testing of it yet. But I'm actually feeling pretty okay about this. I think we're in a lot better state than we were 2 hours ago when we first started. I think we're hitting our objectives here. We've got, I'm just going to go back to slide cam for a moment. Let me just get the right slide up that I want. So if I go back to slide cam, we had 2 topics to tackle tonight. We wanted to call out to Git. And I think with the code we've written, we've got that in place. We've made that possible. We haven't run it yet, so there's a question mark there about whether or not this is a good idea, but it reads well. And we wanted some centralized error handling as well. If I go back to Linux Cam, I think we've met both of these objectives. We've got ourselves something that looks like a scriptish command, which allows us to do things like this, calling out, get the Git version, and bigger pipelines like this where we're working out what the current branch is. We can do both of those. That looks right. Whether or not it works, we'll find out next week, but it looks right. So I'm feeling good about that. We've got some centralized error handling. We've been through the actual Git source code, and we've determined the only error exit code we can look at with any confidence is exit code 129. That seems to mean we've passed garbage into Git. We've passed something in that Git can't understand. We've got an error in the call we've made, which should never happen from the Gitflow extension, we believe. We'll find out as we build out. And we've defined some new errors that we can pass back so that it's easy for us to understand if something's gone wrong, or easier. Because we've got these kind of casts we can do here to determine what kind of error we've got. And we found that blog post about working with errors, which we can look through to see what other useful things there are about working with errors, and also whether we need to add some more helpers to make it easier for these errors, easier to work with these errors. So that's where we are. I'm feeling pretty good about that. I think that's good progress. I think that's 2 hours well spent. I think we've got the core of our Git operations here, and we can now start building out. So what's the plan for next week? I think the plan for next week now is for us to start building out our default backend. This is going to contain all the Git operations that were defined and exist in the existing shell script version of the Gitflow extension. And the reason for that is because we know those commands work today. So they're our baseline, if you like. I've called this default as our default backend. I'm almost tempted to say this is our baseline backend. I may change that name for next week. I'm very tempted with that. We'll see. We'll see how I feel next week. But next week we're going to start building these out. And we'll hopefully go back to getting our init command working. Can we get init command working next week? We may not have enough time. Depends. I might be up for a 3-hour live stream next week, which would allow us to do so. But yeah, we've made some good progress. Right, back to slide cam. So, what do you think? If you're watching this on catch up afterwards, please leave me some comments. Please let me know what you think to how tonight's gone, the progress we've made, and the decisions we've made. Let's go full cam. Were there other options I should have considered that I didn't think about? Do you disagree with the options that I've discounted, and why? Do you like the options I've chosen? All that feedback would be awesome. As always, please remember to leave a like if you've reached through this far. Please remember to subscribe. And I also want to say hello to Oliver, who I believe is studiously watching all of these in his spare time. So that's awesome, mate. And hello to everybody else who's watched this far. Love to hear from you. Love to know a bit more about my audience. Well, stay safe, stay dry in this weather, take care, and I'll catch you next week for the next episode.